Hello, this is a video tutorial for image processing made by Robotics IIT Kharagpur. In this tutorial, we will cover the concepts of basic video processing and callback. Now, what is a video? A video is basically a collection of frames or images that are shown one after the other at a very high speed, so that when we observe them, the eye perceives them, to be continuous. So essentially, whatever methods and whatever modules we have for image processing, they just as easily apply to video processing. All we have to do is, in the latter case, we are taking a video as an input, right? So the input that we take, the frames of that video have to be captured individually at very short time intervals based on the frame rate of the video we're taking. And those frames then have to be worked upon individually, and the output has to be made accordingly. So basically all the modules and everything that we've discussed for single image processing can apply just as well to video processing, only that it will be executed many times, where in case of single image processing it might be executed just once. And we will see in the future tutorials, for all functions and codes, we have provided corresponding programs for both video processing and image processing. So but before we go into all of that, we'll just look at basically how a video is taken as an input and is processed. So the first program will be a very basic program. It will just take an input as a video file and then display that basically. So the inclusions are the same as before. What we need here is, you remember how we had used the pointer to the structure IPL image for the images of frames. So in this case, we will use another type of pointer to a structure. This time it's called CV capture. If you have a look here, CV capture is the data type, is the structure type whose pointers can refer to videos. So and when we want to load a video from the file, while in the case of images we had CV load image, in the case of videos we have a function called CV create file capture, which has only one parameter, which is in the quotes the name of the video that we are loading from the file basically. So the format is similar to how we load images with IPL image. Also we'll need a variable of IPL image type, pointer type, to refer to the individual frames of this video, of course, because after all we are still performing our various image processing actions on the images after all, which are stored in the IPL image pointer types. Then we have a window for the video, and we initialize that window. Now we utilize a loop for video processing. It's quite obvious why, because the video will keep continuing, and we'll take at regular intervals, we'll take frames, and this will keep on going. We usually make provision to terminate the loop on our own, so the loop itself is made an infinite loop while one. And in most of the applications, for robotics applications that you use video processing, where you'll be taking input from the camera and some such, there you will have to have while one, so that the program keeps executing until it's manually cut off or shut down. So that's why we have while one, which is an infinite loop. Then inside the loop, we take individual frames of the video of the capture pointer, and we do that using the function called CV query frame, the parameter of which is the CV capture pointer, which refers to the video we're loading, and it takes individual frames. So frame is basically an IPL image which at a particular instant of time of that iteration of the loop has the frame of the video at that point of time. So in this program we are just interested in showing that video in a separate window. So once we take the frame, just as we have shown images, we use the function called CV show image, followed by the window pointer name and the name of the image, in this case frame. Then we had mentioned how video is a collection of frames shown at a high speed. Generally the FPS is mentioned, is provided along with the video. The video that we have loaded is 30 FPS, so the time between frames would be 1000 milliseconds by 30 is roughly 33.3. so we have used CV wait key 33. Also what CV wait key does, as explained before, it basically waits for the user to press a key, or it waits for or until the time interval inside the parameter is elapsed. It also returns the key that is pressed, a character key basically. So in this case we store that in a character called C, and if C equal to 27, which is the ASCII code of the key escape, then the video will stop, the video will stop executing and it will close. Of course you can also just manually use the mouse button to do the same. So that's that, and then once we're done, we use the function called CV release capture to release the capture pointer, and CV release image for the frame, and destroy for the window. So that's basically the code understood. Let's have a look at how this works. The code has already been copy pasted here. We'll just build the solution. It's up to date, and we run it. And here if you have a look, You see here the video is being executed perfectly, properly, no problems, and is being executed at the proper speed. This is how videos are loaded and displayed. Okay, so let's just shut this. Right. So that was the first important function of video processing. The second basic fundamental concept which will allow us later to use our various image processing modules is capturing from the camera, and this will be of greater use and particularly useful in robotics applications where the robot has an onboard camera or an overhead camera supplied to it, and it takes input from that camera and operates upon the images received from the video feed rather received from the camera, operates accordingly and executes accordingly. So that's that. So the function we'll have here is very simple. It will just initialize the camera connected to the computer, and it'll just take an input from that, as in it'll just take the video feed from that. There are very small differences between the previous function we wrote. We still need a CV capture pointer, but the function we're calling this time is not create file capture, it's CV create camera capture. So that's the function. The parameter is an integer, which is basically refers to the number or the port number of the camera that is connected. So these can be found out by going to device manager and ports. We can find out the type, but that is important only if multiple cameras are connected. If we're using the computer's webcam, or if just one separate camera is connected to the computer, then 0 or a negative number will suffice. Right. So that's that. The rest of the program is absolutely same to the previous one. We have a frame variable, we take individual frames of the capture pointer and we show them. So let's have a look at how this works. We'll just be using direct video feed from the webcam. We'll just copy paste this and build it. Right, so it's built. Now what we do is we execute and see what happens. There you see the camera is being executed and the create camera capture function is being executed and the video feed from the video camera is being taken. So basically that's how the video feed from the camera works. It's very simple. The execution is similar to normal video loading. It's just that only one line is changed, that the capture pointer it now refers to the feed from the video using the function CV create camera capture. So that's that. So that's the second simple concept out there. Now finally, another important concept of video processing, which is particularly important for when you need a very generic or general algorithm based on the specific input at that point of time. That concept of callback is very important. What happens is basically callback refers to a sort of feedback that is sent based on events done by the mouse, as in the mouse you're controlling, over a particular window that we have created and displayed. So for example, if I move the mouse over that window, a certain feedback can be sent. If I have a left click or right click or double click, certain feedback can be sent. One might understand the concept of when a computer goes into a sort of stationary standby mode, or in the sense screen saving mode, and then once you move the mouse again, the screensaver is gone and it goes back to the normal window. So this is something like that. So by using mouse callback, we can generate feedback for certain mouse events on the window. When is this particularly important? It's particularly important when we want to refer to particular areas on the window. We can click maybe a point to get information about that point, or to get the coordinates of that point, or some such activity like that. So we'll be doing a very simple program of callback here. It will be displaying a video, and when one clicks on a particular area of the window, one gets the coordinates of that in terms of pixels, where of course the top left corner is considered as 0, 0. So before we execute the code, there's some intricacies that need to be understood. We use a particular function called CV set mouse callback for the purpose of this. The first parameter of this is the window where you want it to happen. The second parameter is the address of another function called mouse callback. Now this is another important function in its own right. It basically receives the mouse event that's happening and acts accordingly based on that. So what have we done here? We have, prior to the functions, we have created certain global variables called mx, my and chk. Why these need to be global is, as anyone is familiar with the data scope, global is something that will be applicable for all the functions of a program. And since we need variables whose values will be determined in the mouse callback function, and whose later values will be needed in the main function when we get that information rather. So that is why we need global variables. In this case, we are just concerning ourselves with the coordinates, so we'll just have 3 global variables. The first will be mx, which is the coordinate, x coordinate of the point rather. The second will be my, which is the y coordinate of the point, and the third will be an integer flag. A flag is basically something which usually has just 2 values. In this case, 0 and 1. 0 for when the flag is false, and 1 for when it's true. We'll just keep it 0 and 1 when the particular event we're looking for, in this case a left button click happens, then the flag will be raised and the functions will stop executing and we'll move to the next stage of the function. So that is basically the need for the flag. Now inside the mouse callback function, the parameters are, the first is the event, as in the mouse event that's happening. Each of the mouse events has a certain number assigned to it, but for convenience we use the macros. Since we are referring to left click, there exists a macro called cv_event_l button down, which is quite aptly named. So that's that. The next 2 parameters are the coordinates of the point, because we need the coordinates of the point to understand, the nitty-gritty, the point that is being referred to. And the last 2 parameters are not things we need to concern with. The last 2 will not be required for the purpose we're doing. So, and in any case, we will not be required to call this function with parameters explicitly. So the last 2 can be left as is. Just the syntax need to be followed: in flags, void star param. Now inside the function, we first set the default mouse event to 0. Then we check whether the event is actually equal to cv_event_l button down or not. If it is, and that means the left mouse button has been clicked and we can go ahead with obtaining the information. So at that point, the value of x and y at that particular point in the mouse event will be the coordinates that we are looking for. They'll be stored in mx and my respectively, and chk will be made 1. Now inside the main function, once we have obtained the feed from the preloaded video, or if we want from the video from the camera, we then inside the while loop we take individual frames of that. We show the frame itself, and then we set the callback on that particular window where we are showing the frames at the frame rate, and there we execute the function basically. And what happens then is, if the left button down was not the event, if that did not happen, then chk will continue to remain 0. But if the left click does happen, chk will become 1, and then the next line, if chk will then be true, the coordinates of the pointer and the 2 coordinates mx and my shall be printed. And of course, with the wait key, we again will move to the next frame of the video. So this will continue until the window is closed completely. So this way, by clicking on a particular area on the window, we can get the information about that point by knowing its coordinates. So let us have a look at how this works. We'll just copy paste this to our project, compile, build it. Right, now let's run it. So see here the video is playing out. If you take a look also at the screen on the right, you'll see what I mean. So I take, and yes, see there the coordinates of the point are 365, 114. This also makes sense rather intuitively, 365 and 114. Similarly here, the coordinates of the point are 115, 283. Sometimes we find ourselves overlapping because the event happens at the exact point that is the bisection of 2 frames. So sometimes we see that happening. Again we try it. Again the points are 280 underscore comma 229. So basically I clicked at certain points on the window on the screen, and according to the point I clicked at with relation to the fact, this is important to remember, that the top left corner is considered 0, 0. Horizontal is the first component or first index, and the second index is the vertical one, vertical downwards and horizontal from left to right. So based on that it returns the coordinates, and then later on we will see how it will help us get more generalized information about certain pixels or certain areas, which will help us for future modules of image processing. So with that we come to an end of this tutorial. Thank you.